Welcome to the type-along version of Classes and Objects Notes Part 2. I'm going to show you about the Structure tab, which is a great way of previewing what are the capabilities of an already declared class. And we'll also implement a couple of methods for a new class that show how you can take objects as inputs and do things with them, which is a thing we'll be doing a lot of. So let's start from a working solution to your Somerset 4. So here is my Somerset 4. I've got sales item, I've got rectangle. Here's my rectangle class. Here's my main, except I've deleted main. So let's start off by making two random sized rectangles and comparing their sizes. If you want to type along, feel free to type along. If I want two rectangle objects, I will make a variable called R1 for the first one. And normally I'd start running the constructor here, new rectangle, but I want my rectangles to have a random position and a random size. And I don't want to start doing a bunch of like math.random here inside the argument list, just because I think my line is going to get really long and ugly. And I also don't really want to do this here. Don't type this yet. I don't want to do this. Math.random times 100, and then y is going to be math.random times 100, and so on. And then once I'd done that, oh, they can't be ints. So then once I've defined my variables, I can run the constructor. The reason I don't want to do that is because I want two rectangles. So here I could do like x, y, 30, 30, for example. So now it's got a random position and a fixed height. The reason I don't want to do it is because if I want to create a second rectangle, I'll want to copy and paste, which is probably what you would have done in Intro Java, and that's fine for Intro Java. But this is a little bit wasteful, having to have a whole bunch of lines in order to redeclare something. Like this already is starting to look a little bit hard to look at. What I wish I could do is something like this. I wish I could do rectangle R1 equals random rectangle. And I'll just let a method create and return the random rectangle for me. Like, doesn't this look a lot better than what we saw just a second ago with all of that math.random and garbage in there? So this is what we're going to do. You can go ahead and type at this if you want. Pause it. Type. Again, programming by intention. I am imagining random rectangle exists as a method, and now we're going to write it. I'll hit Alt-Enter, allow IntelliJ to create this method for me. Here it is. It returns a rectangle object. That's fine, so I hit Enter. All right, so now I'm going to do all that typing that I said before. So I'll have a double X. That'll be math.random times 100. I'll have a double Y. That will be math.random times 100. And notice I'm using tab completion, so matab.ratab times 100. Width is going to be W. matab, ratab. I'll make the width and height just up to 50. And double H for height. matab, ratab times 50. And now I can actually create the rectangle. I don't want to make a rectangle variable because all I'm going to do is return it anyway. So I'll say return new rectangle and use my randomly generated x and y and width and height. Okay, great. So I've made two random rectangles. How would I decide which one was larger? It's been a while, so I don't really remember what methods are available inside rectangle. Here's what you're going to do. Click on rectangle, and if your project view looks like this, see where my mouse is in the lower left? Find the Structure tab and click on Structure. The Structure tab is going to show you a table of contents of your method. So here it'll show me my attributes. I've got x and y and width and height. And then at the top, it shows me all my methods. So I've got the constructor. And then if you actually click on them, it will navigate directly to those method declarations in your editor pane over here. So it's a nice way of kind of skipping around the class, getting a sense for what it's capable of. Okay, so all right, so what did I want to do? Oh yeah, I wanted to compare the sizes, and I'm noticing in this list of methods, I have area. as one of my methods that returns the area of the rectangle. And that seems like a perfectly great way to compare their sizes. So I'll say if r1.area is larger than r2.area, then s out, r1 is larger. Okay, and if you wanted to, you could test this. You know, it would be pretty hard to test to see if it actually works unless you actually displayed R1 and R2's actual areas, so you should add some more print statements. I'm not going to do it because I tested it back in problem set 4, so I know it works already. Instead, what I want to do is I want to show you how we can replace this with a new way to do it. Instead of directly comparing the areas, I want to be able to have the object compare itself to another object. Right now, our object doesn't have rectangles don't have the capability to compare themselves. That's why we have to do it here in main. We have to ask each rectangle for its area and directly compare them. I want to be able to say r1 dot is larger than r2. And you can think about this as like asking a question. R1 is larger than r2. So we're going to write this method, and it's going to do this same thing. It's going to compare two areas. The only difference is the logic of the comparison is going to happen inside rectangles. So rectangles are responsible for deciding if they're larger than other rectangles, and then we don't have to do it here in main. Okay, so here's how that looks. Let's delete the inside of the if statement. I'll say r1 dot is larger than r2. It's giving me a syntax error because we haven't created the method yet. So if you click your cursor and you hit Alt Enter, we can create the method is larger than in rectangle. I do want it to return a Boolean, so I'll hit Enter. It does take a rectangle as input, so I'll hit Enter. I'm going to name this other. The idea being that this is the other rectangle. So when we're asking is something larger than something else, one of the two rectangles is the rectangle that's running the method. The other rectangle is this input. All right, I'm going to do a side-by-side display here. So I right-click on my tab, go to Split Right. So I can see rectangle on the right, and I'll view main on the left. Let's adjust my sizes here. So this is the line of code that's running, and when it runs, it will jump us over here inside the definition of rectangle to the method that we're just writing right now. Okay, so over here, we want to say something like if r1.area is larger than r2.area. The problem is there is no r1 and r2 anymore. Remember, r1 and r2 were variables that were only defined inside main. Here we're inside a rectangle. So what variables represent the two rectangles who we want to ask about their area? Well, like I said, one of the rectangles is the one actually running this code. So here we see R1 is the one running the code because it's the object, or it's the variable that contains the object that we're asking dot is larger than. So R1's area is actually going to be this dot area. Inside a class declaration, the keyword this is a variable that refers to the object that's running the code. So it's a reference to the object that's running the code. So I can say this rectangle that's running the method, let's also run its area. So now we're getting the area of the object running the code, and we want to compare that area to the other rectangle because you see R2 here gets assigned to other. So I'm going to say if this area is larger than the other one's area, then we'll return true because the answer to are we larger than is yes, we are larger than the other one. Otherwise, I'll return false. So this is perfectly fine. This is not how a more seasoned programmer would actually approach it. Consider this. What I have highlighted right now inside the if statement. If the if statement is true, if this evaluates to true, I'll return true. If this evaluates to false, I'll return false. So all that's saying is I want to return whatever this evaluates to be. So what I'm going to do is I'm going to cut it, and I'm just going to return that expression directly. So this is what used to be inside the if statement. If this is true, now we're returning true. If this is false, now we're returning false, which is just what the other if statement was doing. Only this is a little bit shorter and a little bit nicer. And it almost reads like English. Let's read it. Return whether this area is larger than the other area. That is what we want to return. Okay, so far so good. So we've written one method is larger than. Let's pretend now, once we've determined which rectangle is larger, let's say we want to take the smaller rectangle and move it so that it's centered on top of the larger one. Here's how I would approach this. You know, in intro Java, you probably would have done this. Like once we've figured out that R1 is larger, now you're going to start figuring out like where to move R2, and then here you would say, you know, R2 dot set position to a new position. Instead, I'm going to put all that logic inside the rectangle. I'm going to say, what do I want to do? I want to take the smaller one and center it on the larger one. So the smaller one is R2. So I'll say R2. What I want to do is center it. So I'll call my new method center on. And the object I want to center it on is R1. So this doesn't exist yet, but I'm trying to express my intention. I'm trying to express the idea that I want to be able to tell one rectangle that it's going to move itself to center itself on another rectangle. Let's put an else here. So because R2 is smaller in this if statement, I'm saying R2 center on R1. Otherwise, R2 would be the larger one. So I want to take the smaller one, R1, and center it on R2. Okay, so how do we write this method? Here, I'll just type it this time since rectangle is already open. Here I am at the bottom of the rectangle class. It's going to be a void method because center on doesn't return anything. Instead, it's going to change the attributes of our object. It's called center on, and it takes a rectangle as input. And I'm going to call it other again. Okay, it might not be totally obvious how to do this, though, because our rectangle is defined by its upper left-hand corner. And in order to center a rectangle on another rectangle, it's like I have to figure out where should my upper left-hand corner be so that it's centered on the other one. So this is the situation we're in. We're trying to figure out in the rectangle class how to write center on. This is a place where if I were solving this problem, I would draw a little sketch for myself to try and figure out how to make sense of this. And what I'd do is I'd start with two rectangles, a larger one in purple, a smaller one in blue. And then I'd think about if blue is going to be centered on purple, where is its upper left-hand corner? And how can I figure that out? I think it's probably worthwhile if you want to pause the video and draw some sketches and try and figure out the calculation for yourself. I don't think it should be too hard. It's like Algebra 1. It's like even less than Algebra 1. Fair warning, I'm going to show you. So I think if I want to center blue on purple, let's figure out first where's the center of purple. So the center of purple is, the x-coordinate is halfway between the left and the right-hand sides. And we know how to find the left and the right-hand sides. We have methods for those, left and right. So I'm going to find the midpoint by saying left plus right divided by 2. Another way of thinking about that is the average between those two coordinates. Same thing for y. I'm going to find the average between the top and the bottom y coordinates. Okay, so once I know where the center of purple is, I want the center of blue to be located there. But I can only set blue's upper left-hand corner. So the question is, if blue is sitting where I want it to sit, where is that upper left-hand corner? And now that I've drawn this picture, I can see, if I start at the purple center x-coordinate, all I have to do is subtract half of the blue's width. And now I've got the x-coordinate for the upper left of blue. For the y-coordinate, I'll start at the purple center y-coordinate, and I'll subtract half of blue's height. Just a quick note, you might be thinking subtract. I'm imagining the coordinate system that we use for graphics, where 0, 0 is in the upper left-hand corner. So that means subtracting y values moves us up on the screen. If you're imagining a coordinate plane more similar to math class, you usually imagine quadrant 1 of the coordinate plane, where 0, 0 is in the lower left-hand corner. And in that case, subtracting y values would take you down towards the axis. Either way is fine. I'm going to use the graphics coordinate system just because that's what I'm used to when I'm programming. But for the purposes of this assignment, I don't care that much. This could be plus or minus either way. Okay, so let's go ahead and now implement this idea. So here's center on. So the first thing I want to do is figure out what's the center of the other rectangle. Because remember, we're centering on the larger one, and other is the larger one. So I'm going to define a new variable called center x. That will be the average of the other rectangle's left and right-hand sides. So we'll say other.left plus other, and again, tab completion, O tab dot R, enter, divided by 2. Let's do double center y, O tab dot T for top, enter, plus O tab dot B for bottom, enter, divided by 2. All right, so now we've got the center x and y. And I could say, let's take my own x coordinate and set it to be center x minus width divided by 2. Well, let's do it that way. So this dot y equals center y minus h, enter, divided by 2. So that works. A different thing we could do is we could run our own setter method. I could say this dot set position, and then the position is going to be center x minus 8 height over 2, center y minus width over 2, and then center y minus height over 2. And in each of these cases, I was typing like one letter for center x, one letter for width, one letter for center y, one letter for height, and I'm letting autocomplete do all the rest. Okay, so that's a little shorter, a little nicer. So in today's problem set, you'll be working with a couple new classes, and you'll be doing this kind of thing. I want to leave you with a thought that I did not put in the other video. If I was going to actually write this as part of a program I were actually writing, even this feels less helpful to me than a different thing that I'd want to do. Like here, I'm going through a lot of trouble to figure out where the center is, and then I'm trying to set my own position to the center. What I wish I could do is something like this. I wish I could say other.getCenter, something like this, and then I wish I could set my own center to the other center, right? So imagine I could ask the other object, where's your center, and save the center, and then say, let's set my own center to be that position. This is like conceptually the simplest, and we could do that. And don't type along, but let me just show you what that would look like for me. A center is really an xy coordinate pair, so I'm going to have a point object. I imported a point object. So get center, I need to create that. What is a center? I'm going to return a new point with an x and a y. The center is going to be left plus right divided by 2, except I need some parentheses here. And then top plus bottom divided by 2. So now, oh, that serves me right. I imported point, but point only has integer coordinates. It doesn't have doubles. Okay, so let's go back. Let's not import point. Let's just make our own point really fast. And in Intro Java, it was a whole big deal to make a new class. Like it probably took you a whole class period. In AP Computer Science, it shouldn't be a big deal if the class isn't complicated. So we're going to have an x and y coordinate. I'm going to make the constructor. I'm going to make getters and setters. And you can see that this whole process took less than 1 minute. And now I have the point class that I need. I'm back in rectangle. Great, so now I can get the center, and the center is a point object. And now I'll set my own center to this new point object, which I'll call location. All right, so how do I set my own center there? I'll say this dot x equals location dot get x minus my own width divided by 2. So the calculations are kind of the same as before. Get y minus height over 2. Okay, so that whole thing took me, I don't know, 3 minutes, 4 minutes. You know, the class is a little bit more complicated now, but I've created methods that might be helpful for other things in the future. Getting my own center, setting my center to be something. Now center on I could express very directly. See, the code is like extremely short, extremely easy to read, extremely easy to think about. So this is going to be kind of the gold standard for us when we're programming, is all of our code should express our like the logical intention for the method as directly and as readably as possible. Okay, good luck. But, you know, it's not going to happen right away. Doing this takes a while to learn how to think this way, and that's going to be your goal as students. You're going to learn how to think this way. Okay, good luck on the problem set.